Okay, so this lesson is about power. Okay, 1 minute. So we can say that power is actually equal to voltage times current. And we know that voltage is originally equal to resistance times current, and we know that current is actually equal to voltage over resistance, which means that we can get another two equations for power. So if you cover up voltage, then you get R times I instead of voltage, so it will be R times I, which will be I squared times R. This is the second equation. And if you keep voltage but you remove current, so you'll get V over R, so we're going to get V times V over R, so we will get the power is equal to voltage squared over resistance. So let's do some examples. So example 2 here is saying the following: a 1250 watts radiant heater is constructed to operate a 115 volts. What's the current in the heater and when it's operating, and what's the resistance of the heating coil? So in question 2 we have the following given. We have power and it's given as 1250 watts. Then we have voltage, which is given as 115 volts, and they want us to find the current and they want us to find the resistance. So we can use the following to find current. So we know that power equals to voltage times current, which means that current will be equal to power over voltage. So power, which is 1250, divided by the current, which is divided by the voltage, which is 115. So we get that current is 10.86 amperes. Then they are asking to find resistance. You can use two methods to find resistance. You have two approaches. First approach, you can use that power is equal to voltage squared over resistance, or you can use that voltage is equal to R times I, and you can find it using the power, or you can find it using Ohm's law. Also you can use visibly power equals to I squared times R. So you have three alternatives. So let's use this one. So power is equal to V squared over R, which means that we can change positions of P and R. So R will be equal to V squared over P, which is equal to 115 squared over 1250, which will be 10.6 ohms. This is for the power lesson. Let's see if we have another question. How much charge? Okay, question 3 and 4. So in question 3 they are saying the following: they gave us power and it's given as 18 watts, and they told us we have 9 volts across it, so they gave us the voltage, which is 9 volts. They are saying how much charge does it go through the device in 4 hours. So we know that in order to get charge, we can only get it from this equation, which is current is equal to charge over time. So we need to get current first. So this is the first unknown, which is the current. So we know that power equals to voltage times current, which means that current is power over voltage, which is equal to 18 over 9, which is equal to 2 amperes. So now we get the current. In order to get charge, we do cross multiplication between current and time. So we get that Q is equal to I times T, which is equal to 2 multiplied by, we have time given in hours, we need to change from hours to seconds. So from hours to seconds we multiply by 3600, and this will be 2.88 times 10 power 4 coulombs. So question 4 is saying the following: so an unknown resistor is connected between terminals of 3 volts battery. energy dissipated in the resistor is given as 0.54 watts. Then they are saying the same resistor is connected between terminals of 1.5 volts. What is the new power? So we'll do the following. So we know that power old is equal to 3 squared over R unknown. Power new, now what happened to the voltage is that the voltage got divided by 2, so we can write it as V old over 2, all of it squared divided by the unknown resistance R. So we get that power new is equal to V old squared over 4R, which means that power new is equal to V old squared over R multiplied by 1 over 4. So power new is actually equal to power old over 4. How did we get this? This is because this is the core of our solution. They told us that voltage new is equal to 1.5, voltage old, V old is equal to 3. So V new is related to V old, that it is 3 over 2. This is how we know it. Or you can do it in numbers. And alternatively, you can say the following. Power old, which is given as 0.54 is equal to 3 squared over R. So you can calculate R from this. So we get that R is equal to 3 squared over 0.54, which is equal to 16.66 ohms. Now we get R, so you just say that power is equal to V squared over R. So V new, which is 1.5 squared over 16.66, and you will get that it's approximately 0.135 watts. So you have two approaches to do this. Okay, I'll do the last question also. So question 6, we're saying the following. So the power is given as 2 kilowatts, and then they told you that the dryer has a length of 80 centimeters. So the length is 80 centimeters and 10 centimeters got removed. So the remaining length now is 70 centimeters. So we say that length new is equal to 70 over 80 multiplied by length old. Because length new is less than length old, so we get that L new is equal 7 over 8 times L old. Now we go to the power equation. We say that the power is equal to the following. It's equal to V squared over R, and we know that R is actually rho times length over area. So we didn't change the cross-sectional area, they changed the length. So we say that power is equal to V squared over rho. This is length new. Now length new we replace it by 7 over 8 L old over A. So what's going to happen now? We want to rearrange this. So we can say power is equal to V squared over 7 over 8, and here we have rho, L naught, and we have area. So area is gonna go up, and it's not changing. Well, 8 is gonna go up, so power is equal to 8 over 7 V squared over rho LO over A, and all of this is R old. So power new is equal to 8 over 7 times power old, which is equal to 8 over 7 multiplied by old power, which was equal to 2 kilowatts. So 8 over 7 multiplied by 2 kilowatts will be 2.3 something. So 2.3 kilowatts.